Hello everyone. So today I'll be discussing about the VSEPR theory or the valence shell electron-pair repulsion theory. In studying molecules, this theory is the one that predicts on how atoms are being arranged in a three-dimensional space in a three-dimensional molecular geometry. Since atoms are being surrounded by clouds of negatively charged electrons, the VSEPR theory suggests that in order for these atoms to reach their lowest energy level, they have to repulse each other and they want to be as far away as possible from each other. Studying the molecular geometry of a specific molecule is important as it greatly affects on how this specific molecule behaves and how it reacts and it does chemistry. Today, we are assigned to explain the three most common molecular geometry structures, which are the linear, the trigonal planar, and the tetrahedral. In this video, we'll be using these balloons in order to demonstrate on how these atoms in this molecule are being arranged in a linear molecular geometry and how they repulse each other that eventually it takes form of this linear molecular geometry. So a linear molecular geometry will look like this. Two atoms attached to a center atom, and thus, because of the electrons that are clouding these two atoms, they repulse each other and eventually it gives form to this molecular geometry. They have, since there are only two of them, they have a band angle of 180 degrees since they repulse each other in this direction. The next one is the trigonal planar molecular geometry. So the trigonal planar molecular geometry is going to look like this. Three atoms attached to a center atom, and they have at around 120 degrees band angle, and they repulse each other that it eventually gives form to this kind of molecular geometry. So it would look like this, looks like a triangle. And the last one will be the tetrahedral molecular geometry. This is the form of a tetrahedral molecular geometry. They have four atoms attached to a center atom, and they have the band angle of around 109.5 degrees. This is not exactly how it's going to look like on a molecular level in a three-dimensional space, but this is the simplest form on how I can represent a tetrahedral molecular geometry. It's going to look like this. As they repulse each other, it gives form to a tetrahedral. And that's all for today about the VSEPR theory.